Good evening, everyone. Can you hear me? Can you see me? How's it going? I didn't actually have to change anything for the first time in ages. There's usually some button I gotta press, or some knob I gotta tweak, or some slider I gotta move. But everything kind of seems okay. Overall audio is a touch low, you say? Turn it up. 10 out. God no. I do not plan on doing what we did last week. That nearly killed me. Audio's low. Okay, hang on. Just give me a second then. How about... Tell me if this goes up. How about that? Is that any better? Very hard for me to tell because I don't think that actually changes anything in my ears. Maybe it does for you guys. Still the same? Maybe. Technology's hard, man. Alright, how about I do this? Move that up. How about that? And how about that? Is that any better? Still the same. Pressing the buttons and stuff, moving the dials. Volume's really low. Is it really? This isn't cool, man. Is it across the board or is it just the mic? Radius. Sorry, radius. Redders 2056, thank you very much for the sub. That's very kind of you. Can't hear anything across the board. Are you all trolling me? Okay, hang on. No music or anything. How about that? Is that any better? I'm guessing not. Music and voice okay. Your stream usually low volume usually. Yeah, okay. Okay. Well, there's something going on that I clearly need to tweak. Hang on just a minute. Let me see if I can... sorry about this. I don't really like to start a stream with this kind of nonsense. Sounds like OBS master volume. Yeah, I've got that kind of cranked up, to be honest. I've got the microphone cranked up as high as it can go. Everyone else is hard of hearing. Yeah, like, for some reason, like, I haven't changed anything. Just a sec. Background's too loud. Okay, how about that? Is that any better? I've wound the background volume down again. Sound. Manage. Properties. If I, oh, this has actually gone up again. Okay, I'm just changing something. Turn it all up to 11. Bigger. Properties. How about that? Is that any better? Can you hear me now? Did that actually improve anything at all? Yep. You can. Okay, you can hear me now. Man, good for you. Can you hear the background still? That's the voice fixed. Okay. And the background? Can't hear the background. Man, what a mess. Okay, how about this? So you can hear the BG if you have headphones on. Okay, how about that? Is that better? Wish there wasn't so much lag between. There we go, that's better. So you can hear the background and you can hear me okay. We good? Strange. I hate computers. Yay! Yay, yay. Alright, let's move on. Sorry about that. I kind of felt that everything was going to be good, but clearly I am wrong. And, first flag soul. Captured the sound. So, good evening, everyone. Thanks for joining in. Sorry about the shenanigans with audio and whatnot for some reason. I haven't changed anything. Well, not at least not deliberately. I haven't rebooted. Haven't done anything like that. Yeah, whatever. Here's what it is. So, for those of you who joined in last week and probably bailed after however many hours, we did eventually get shells, and the recording for that is up on the Vimeos and the YouTubes. It did take 6 hours and 50 minutes for the shell to come in. I'd like to blame the fact that the code that was running the shell was really slow, but it was me. It was me. But we got there in the end, which was pretty exciting. So I'm pretty happy about that. So today we're going to do something similar, but the challenge that we're tackling appears to have a lot more solves than the previous one, so I'm hoping it's not going to take as long. Famous last words, right? Now, before we continue, make sure you have your tea. I have my Dong Ding Oolong again tonight. I have a sore stomach. I'm hoping that this tea is going to settle it down a little bit. So, grab your tea. We're in for a fun ride, I think. Now, what I did after last time, because when we were doing our CTF challenge last time, I wanted to use Ltrace inside my Pwn Tools Docker container, and it wasn't there, so I've kind of adjusted that a little bit, and now it's in there, so in case we need to have it, we can see what's going on using that. So, just like last time, actually I will duck up into the corner, and let's spin this up. Okay, so, now, the challenge that we are doing, I did the same as last time, and I pulled down the binary and made sure that it ran and that everything was good so that we can avoid doing shenanigans like what I just had to do with the sound. So it looks like it's got a very similar setup in that you have a binary that you can download, you've got the source to it, and it's got its own libc. So what I did in preparation was I set up the stuff. So we had everything here that we needed and that it ran like last time. So if you have a look at exploit, you can see we've got the basics in here. Okay, basically exactly the same as we did before, but clean. It has the LD preload stuff set up, it's ready to go, etc. Okay, so any questions before we continue? Clearly, what I should probably do, we're going to Vim display. We're going to have this up and running regardless, and inside here we will also have the ability to execute it. Now before we do anything, let's have a quick squeeze at the source. So let's edit, not W, E. Okay, so I didn't adjust the color scheme. My bad. Is what it is. So this is the source code to the app, and the app looks like this. So you get a fairly basic menu. You can forge a sword, synthesize two swords, show a sword, destroy a sword, harden a sword, equip a sword. So new sword is forged, sword index is 0. Okay, so what does it mean to like equip? Equip 0? Okay. Maybe you have to like forge it before you can equip it or something. I mean, harden it or something. I don't know. So, okay, well, if we forge a sword, and then if we forge another one, does that, yeah, it just increases the index. So if we synthesize 2 swords, so 0 and 1, forge 2 swords now. Okay, so show a sword, 0, ooh, Blade Master is angry. I'm not doing very well. Okay, so, alright, let's forge 1 and show 1. Show 0. The name is null. Excellent. Excellent. Sword Tails. Hey, Menz. By the way, good evening. I haven't named each and every one of you like I normally do. My apologies. So, remember, hacking without T is very uncivilized. Greetings, Menz. Greetings, Tom. Benzies. Wilbur is in. Civ is in. We got RamZX00. Greetings to you. For Christ's sake is in again. Seska, nice to see you as always. Torpran, greetings. At Wolf, a regular Tom, and who else? Who have I missed? Serializing's in as well. For Christ's sake. Zorcat. Wonderful to see you. And B-Man's joined the crew as well. Good to see you, B-Man. Thank you for the follow, Digimon. Welcome to the stream. Thanks for joining in. Remember to sing out if you have any questions along the way. Sword is an element of an array. Well, I assume that's going to be the case. Sluthlfa. We're going to have a look at the source in just a minute. I just thought I'd have a quick squiz. So if we forge 1 and destroy 1. Okay. Nothing particularly bad happens there. So if we forge 1 and then harden. Oh. We can harden a sword. What's the length of the sword name? I don't know. Please input sword name. Ooh. So is there actually a timeout that's killing this? Maybe there is actually a timeout. Late to the party, but I made it. Greetings, Dean. Good to see you, dude. There must be something going on to kill it, so let's have a quick squiz. Alright, so what do we have? We have show menu. Gee, I wonder what that does. Should we go top to bottom or bottom to top? Let's go bottom to top and have a look. Oh, here we go. If someone can print some ASCII out, that should be better. Okay, so get rid of buffering as always. Okay, we got this call to alarm. Okay, so sig alarm, alarm handler. So this is just going to terminate the process. All right, so maybe what we need to do to begin with is actually patch this binary a little bit so that it doesn't constantly bail out. Alarm time, how long is that? Doesn't feel like it's very long. 30 seconds. So it dies in 30 seconds. Hooray. Yeah, I'm getting the feeling that we can probably patch that out. I actually don't have on this VM, I don't think I've got any nice hex editing utilities. So anyway, we'll have a look at that in just a minute. We'll keep reading the code for now. So we've got a buffer that we're reading input into, which is 32 characters long. So what do? We basically say go and read a command. Show the menu, read a command, convert that command to an integer, do the basic switcheroo, and hey, have a look at this. Case 7. Print thank you, break. It doesn't actually exit when you quit. Is that true? Yeah, okay. I don't know whether that's useful or not, but hey. Forge time might be what we hit. Yes. Let's have a squiz at that. Forge time. Forge time. Oh, okay, we're just sleeping. With forge time, we're only sleeping. Okay, so when we create a sword, what do we do? Pick sword free slot. Okay, so we are iterating through what appears to be a global array of swords, sword lists, and looking for the first one that is not used according to this. Should probably set number so we can see the lines. Hello, Usiubach. What are we doing? We are doing a binary exploitation CTF challenge from Pico 2018, and we are just having a look at what the code is doing to see if we can figure out if there's anything suspicious up front that will open the door for us. So yeah, very early days. Very early days. Thanks for the follow, CD Zeno. Hey, Vendetta, good to see you. Oh, you watched the last one. Wow. That's right, you did. You did. I think did you chimed in on stream, didn't you? I don't remember. It was a long night. Yeah, 7 hours. That was rough. I do not intend on going for 7 hours tonight. Anyway. Okay, so we find the first sword that is marked as not used. Okay, so that's clearly useful. Okay, so we've got a sword list that has, where are we at? It has a pointer to a sword and a flag that says whether it's used or not. Okay. And then we've got this sword structure which has the length of the name, the weight of the sword, the name of the sword, and ooh, what's this? Line 18. Use sword is a function pointer. Well, that's immediately suspicious, isn't it? So that's a function pointer that points to a function that takes a pointer to a character, so a string, and does what it would will with it. So where is that actually set? What do we got here? Use sword points to who? I use sword blah. It is so cool. Okay. It does feel maybe like a little bit of a contrived example that will allow us to maybe hijack this pointer in some way using the classic things like use after free or whatever. So we have this is hardened flag. Does that provide anything useful? Hardened sword. So if it's already hardened, then we don't do the hardening again. Otherwise we set the hardening to 1. So what does that mean? That means we can... Okay, so there's a limit on the name length. Max sword length is actually the name length. So what is that? That is hex 100. Okay, so that's a significant size sword name. Okay. Alright, so when we harden the sword, we give it a name. And what do we do here? Okay, so we read in the okay, so we read in that many characters based on how many we said. Name len. Yep. So length is what we specified up here, and then we iterate what appears to be name len times, so length times, and we go sword list slot, so whatever slot we're currently referring to, sword name. Okay, so that's just writing character by character into the buffer. Okay, so it is reading up until the new line, yeah? And then terminates the very last slot. Okay, so is that going to allow us to go 1 too far? Oh no, hang on. Malloc actually has the len plus 1, so at the very most it will still squeeze in at the end. Okay, that's interesting. So what's interesting about this? Then you get the weight of the sword and we sleep. Ugh. Sleep weight plus 1 times however. Geez, that's a long weight. So I guess we won't be doing that. Maybe we need to specify a weight of -1. A weight of -1 would actually give us the ability to forge a sword, harden a sword without having to wait at all. Seems fine to them. What does the weight do? Is that actually used anywhere? Other than printing it out, it looks like no. Okay, that's fine. Long way. I didn't pick up on that, Tom. Okay, so what else we got going on here? We have if it's hardened, then we bail out. If the okay, so this is interesting. So if we specify a length that is too long, says the name is too long and we free the sword. Where else are we freeing? Okay, so there's a call here to free sword. So when we free the sword, that frees the sword and it frees the name associated with the sword. Oh, excuse me. Okay, so yeah, okay. Alright, so when this function frees the sword, it's marking the slot as no longer used. Frees the sword and the sword name. But this line here, okay, it frees the sword. It doesn't free the sword's name, and it doesn't appear to mark the slot as unused. So maybe we've got a use after free thingy going on in there. Okay, so what else can we do? Can you double free? Can you double free? If the slot is less than 0, the slot is greater than all the okay, so the slot has to be used for it to be freed again. Okay, so there's at least no double free here. I guess there is a double free if you do that other thing first and then come in here with the slot still marked as used, and then it tries to free again. Okay, so maybe that's abuse. Skorov, greetings to you. Welcome back to the stream. Nice to see you again, mate. Yeah, so that's interesting. That's interesting. Does getInt do anything particularly interesting? GetInt just says create a buffer, read in characters until a new line, or until we've read enough. Null terminate and return ASCII to integer. String. Okay. Pick sword free slot. Yeah, we looked at that before. So that's just iterating through and finding the next sword that has been marked as free. So where is that used? That's when we create a sword. So when you create a sword, you get the sword that's currently free. Then you malloc for the sword. Indicate that it is now used and that it's not hardened. Doesn't look all that bad. I guess you're not... We are using malloc, not calloc, for example, so it's not like you're zeroing out memory. So other than indicating that this is no longer hardened, if you free the sword, sorry, if you create the sword and then you harden the sword with a name that's too big, and then what do you do? I know it's still in use. Yeah, I don't know. Maybe I'm getting ahead of myself. Any thoughts? Does look like there's a couple of things in here that are going to allow us to break stuff. So maybe we should just have a bit of play. Okay, so in our exploit, what have we got here? So I'm not doing anything other than just attaching and doing the do. So let's have a squiz here. Huh. Opening connection. Oh, okay, yeah, have a look at this. I decided to check. That needs to be 1, not... So what I was doing here is, like, if I pass something on the command line, then could be anything, then local is effectively then false, and we connect to the target ready to throw our exploit at it. So let's just do that again. Oh, didn't mean to do that. Didn't exploit. So we should work locally. Here we go. All right. So As you can see, so let's do a quick check sec. Okay, so there's canaries enabled, NX enabled, nothing particularly special there. Partial railroad, position independent stuffs is all disabled. Okay, so clearly this is all going to land in the same spot. The SS is there, so that's where we're going to find the GOT. What else do we have? C, LD, and there's nothing here marked as the heap just yet. Let's continue, and we'll create a new sword or two. Ah, crap! We've got that alarm clock that I'm going to have to patch out. Hey. Oh, okay. So maybe if we disassemble main, and then yeah, what I want to do is get rid of this call to alarm. Hey, I'm sorry. Yeah, get rid of the call to alarm without necessarily patching that call out. I suppose I should just patch it out, shouldn't I? I don't really have a nice binary editor. So let's just break at main plus 73. Can I do that in here? Break main plus 73. Is it going to be too late? Oops. Maybe it'll be too late by then because we're doing the attach thing. Breakpoint. Is that right? Breakpoint. Oh, okay, nice, because we're at a read line. Yep. So in that case, one thing that I haven't been able to figure out is instead of gdb.attach, if instead of doing the attach thing, we go phone.process, instead of phone.process, we go .gdb.debug, and we effectively do, I think it's exactly the same thing, gdb script equals gdb commands. This is one thing that I was mucking around with before. We go. Ah, there we go. Oh, that worked perfectly that time. Yeah. The old BTBAM strategy. Wonder where you got that discussion from. Okay, so once we've hit this breakpoint, what I want to do is just skip over it. So I'm going to go set rip equals rip plus 73 to 78. So let's go. That's 5, isn't it? Rip plus 5. So hopefully that means that if I SI, then we're good. Okay, so that means we won't have to worry about attaching, having the alarm kick in anymore. How goes the work on getting Doom soundtrack as background music? I haven't actually considered that for a little while. Okay, so let's forge a couple of swords and then look at the VM map. There you go, we can see the heap now. So we will definitely have stuff in the heap. Okay, so if we then, let's have a look. If we do what were we going to do? We were going to harden, wasn't it? It was harden the sword. And in hardening the sword, we were going to choose something where the name is too long. Yeah. Yeah. Okay, so if we harden a sword at 0, what is the length of the sword? Because I am an absolute Gumby. It is 256. I just thought I'd check. Let's pattern and a hex editor for changing. Yeah, I was thinking maybe I should do that. Okay, so we want to go 257. The name is too long. Okay, so at this point, according to what we have in here, too long. So we should have freed that sword, but it's still currently marked as in use, right? So if we tried to interact with it now, like show a sword at 0. Yeah, okay, look, it's still working, even though I guess the sword has been freed because, you know, the memory has not been used up. So this begs the question then, if we forge another sword, index 2, they should be taking up the same bit of memory, right? Because we've allocated a new sword. So that means if we harden, let's say we harden index 2, and it's only, I don't know, 10 characters high there, like so. The weight is going to be -1, so we don't have that stupid timeout. Okay, so if we show a sword at 2, the weight is -1, and hi there. So if we then show a sword at 0, do we get the same thing? Aha! Okay, so they are overlapped in memory. Winning. Winning! Hey, look who it is! RFC Hacks is back in the house. Good to see you again. Okay, so we have 2 swords pointing at exactly the same spot. So we know that we're able to reuse the memory at this point. Okay, so does that mean that we have the ability to... Well, we need to know how much memory is allocated for that sword. Because if we can... okay. If we have 2 swords, right? So if we have 2 swords, we harden a sword and give it a length that's too big, and we end up freeing that sword. And then we harden the second one, right? And then once we've hardened the second one, we give it, we give it the same name length as the size of the structure for the sword. Then we should be able to point our name at that sword, at the same spot. So if we can then write our name to the same spot, we effectively have the means to control all of this sort of stuff. Does that seem reasonable? Including a function pointer. So just for shits and giggles, if we just filled this up with nonsense and then tried to, you know, use it. Actually, I don't actually have it set up. Crap, that was dumb. I will make sure that I am ready to do drawings on the next stream. I don't have my other VM ready to go that I do the drawing directly, and so I'm sorry about that. I know, it's terrible, isn't it? Yeah, okay. Okay, so what I'm thinking is if we let's whoops. I think there's only one file to edit. Ah, there we go. Alright, so what we're going to do then is to start with, maybe we need a couple of... Okay, let's do this. We'll make a couple of helper functions. Where should we do that? Maybe we should do that here. Def forge. Okay, so that's going to give us... Actually, you know what I think I might do is I might exit out of that here and leave this up as is, and then I'll move that puppy over there. And then I go cd string pico binary. This is, what was it called? Sword. And we gvim the exploit and sword. Oh. Sorry, I just want to open this up in something that's a little nicer to interact with, and then we can exit out of that. Okay, so maybe this will be a little bit easier to interact with. And then maybe my indenting and everything will be nice. Yeah, there we go. I've got all my shortcuts back out, and then I can just flick back over here and off we go again. Alright. Sorry about that little sojourn. Okay, so if we go def forge, not force, and we go, I'm gonna pass, because I'm a bit pedantic, I'm gonna pass things around. So maybe I should put this up here. Okay, so according to the menu, we basically want to get to quit. So we'll go p dot send line after. Is that what it was? I'm pretty sure that's what it was. Quit. Is there a space? Or a new line? There's a new line. Okay, so send line after, we're just gonna hit 1. And then, should we want, no, we probably wouldn't want to do send line after. Maybe we should do it the other way and assume that the menu's already been rendered. Yeah, maybe we'll do that. We'll go send line. Or just send line. We're gonna have to give it an actual character one, not the digit one. And then go p rec v until quit. Is there a full stop? Yes, there is. Quit, new line. Okay, and then we can ignore that. Yeah? Okay, so that will allow us to forge a couple of things. Let's just make sure that works. So we can go forge p twice. And then when we go interactive, we should be able to see 2 swords in action. Alright, so let's exit out of that and rerun. Do the set rip thing and continue. Okay. Hey, does anyone know, can you automate in GDB an activity to do when a breakpoint is hit? Because that would be cool. Like you can with WinDBG, you can say when this breakpoint's hit, perform some scripting style actions and then move on to the next thing. Does anyone have any familiarity with that? Hook stop. Is there a hook stop? Is there? Maybe we can have a play with that, and then I can just automate the skipping over the alarm. That's something we can all learn together in just a minute, I think. Okay. So at this stage, we should be able to... What are we going to see? We should be able to see a sword, right? There you go. There's one, and we should be able to show the second one as well. Yeah, okay. So that effectively works. GDB in it. Yeah, but I want to make it specific to this project, not actually putting it in GDB in it. But yeah, we'll come back to that. Okay, so what we're going to do is we're going to forge 2 swords, and then what I want to do is I want to harden the first one. So I want to harden it with yeah, we're going to harden it. We're going to start at index 0, and the name length we're going to give it is 0x101. We'll actually put this in the helper, so we'll go def harden. We've got the process, we've got the sword index, we have the, let's p, hang on, we'll call that index. We'll have the size and the name. Now the name we're going to leave like that. Hey Scooches, hello. How you going? Good to see ya. What's cracking? What's crack-a-lackin'? Just doing some more binary and hoping it's not going to take 7 hours like last time. Although, from the pace that I'm seeing, just from reading the code and seeing some shenanigans, I think we're pretty much at the point where we can see the entry point, which is significantly better than last time. Yep, you can add command GDB commands, right? Yeah. So what I want to do is I want to set a breakpoint and then run, and then when that breakpoint is hit, I want to do a command and then continue. Hey Jay, how's it going, mate? Nice to see you again, dude. Okay, so here we're going to go p.sendLine. This time we want to, where is it? So harden is 5. Okay, so where's my, I'm going to go sendLine 5. p.sendLine. So what happens after that? We should actually do it, shouldn't we? 5. What's the index of the sword? So that's like send line after sword. Is there a question mark? Yes, there is. Question mark new line. So after that, we are sending the index, which is the basically the string representation of the thing. Do you guys usually go str of an integer? Is that what you guys usually do? Yeah. My Python is so bad. One day I'll learn how to do dev. So we pass that in after, and then once that's done, so the index of the sword is going to be 0 in our case. This is the length of the sword name. Okay, so where are we at? Length of the sword name. So we'll do that. Send line after name. That's going to be str of size. Now, what we need to do is we need to go if size is less than or equal to, then we want to go p.sendLine after. What is the next one? So if we just 432, name is too long. Okay, so I did the wrong way, didn't I? Let's harden a sword again. Index is 1, length is 45. Please input the sword name, and then what is the weight? We're always going to put -1 for the weight because we actually don't want to wait. So we get to name.newline, and from here we're going to send whatever it is that we specified for the name. We are also then going to go and specify the weight. And here we're always going to put -1 for reasons we have already described. Bad, other than the weather, yeah, know the feels. Python 3 fixes like, yeah, I'm sure Python 3 does a bunch of stuff better than what I'm doing. I'm kind of used to just hacking with this horrible stuff in the meantime. Okay, so what are we going to do? So yeah, we're only interested in doing that when we actually specify the right length. So what's the weight? That's going to be -1, at which point we're done. Okay, so we can then go p.recv until quit new line, which I'm going to repeat a lot, so maybe I'll have a little flush function like so, which basically does this. So here we can just go flush p, try and reduce a bit of the old copy pasta. So we'll start with flushing p to get to the end of the menu, and then we're going to forge 2. We're going to harden 1. What we need to do, hey Ozjak, How you going, dude? Welcome to the stream, mate. Hope you're doing well. Okay, so we're going to harden that one and fail at it, and then the next one we're going to harden. We're going to harden that one. We're going. Oh, we need to know the size. We do need to know the size. We can guess it though, right? Let's have a look at the source. Let's have a look at the source. Okay, so this is 64-bit, right? Ints are 32-bit, so 1, 2, 3, and 2 pointers worth 8 bytes each. So 16, 24, 28 bytes is what I'm seeing. Let's just validate that, actually, by using ltrace. Ltrace sword. So if we forge a sword, we malloc 32. Okay, so that's 28 rounded up to, is it D-word alignment? It would be D-word alignment. Yeah, D-word alignment. I think that's what that is. That ain't no Black Yeti. Yeah, I know. I'm using this one because this has actually got tea stains in it, but the other one that you got for me is all fresh and clean, so I just use that for water. Yeah, you like that? So I'm keeping that one in nice, pristine, watery cleansiness condition. Okay, so before we continue with the split, so we know it's 32, which means we're going to need to pass in 31 as the length because it's going to add 1 for the null byte, yeah? You did get both of them, that's right. This was a birthday present for me from ages ago, but I had already been using this for tea. So that's why I thought, well, I'll continue using this one for tea, and I'll use the other one for water. But as time goes by, I'm pretty sure that I'll probably forget. Okay, so yeah, 32. 32 is what we were going to do, right? So let's do 31 bytes. Actually, let's do some constants. Sword struct size equals 32. Make this a little bit more readable. Sword struct size -1. We'll go sword name max size equals 0x100. So then we can actually go +1, and then we'll put these up here. Because then we can put this in this bit here. Sword name max size. Alright, so hopefully that makes things just a little bit more readable. So we're going to harden it, and this time let's just fill it with A's. Sword struct size -1. And we'll just see what that does. Now ideally we'll see that memory allocation happen. And when we forge a sword, let's just hit that breakpoint for a sec. This has is it forge sword? Forge sword? No. Forge time. Forge a sword. Come on. A new sword is for that's create sword. Of course it is. This as create sword. Can't type. Okay. So when we create a sword, we want to break on the very first malloc call that happens here. So let's break there. Okay, so we got another follow. No. Anonymous gift. Ah, man, the anonymous gift is back. Peleus, I didn't realize you were on stream, dude. Greetings. Where are we at? Maybe he isn't. Break, create sword plus 47. So that means we should then be able to, of all the people, yeah, I know, clearly I know Peleus is. There's a few that have semi-regulars that have scored. Thank you very much, Lee. That's very nice of you. Peleus will be delighted. Seriously though, very, very kind of you to do that. Thank you very much. Okay. All right. So we're going to do the jumping over racks rip thing, and then we will continue. Oh yeah, so this is our first sword being allocated. So that should return, what we got here, a pointer. So that's where the first sword is allocated. 1, 0. Now, what I want to do is make sure that when we malloc after hardening, that we also set a breakpoint there. So if we go disas harden, I assume it's harden sword. Okay, there's a malloc in here that happens afterwards. Sword. So we go through. I want to make sure that the malloc actually does what we want it to do. So that is there. So it's after, it's between a printf and a yes. Okay, so let's have a look through here. Put s malloc. Where's the printer? That's okay, so that's the freeing of what appears to be the sword. So I would assume that when we get to here, where's the call to printf? Did I make a mistake? Or is there multiple? Puts and then exit. Is there only one malloc in here? I think there's two, isn't there? There's one for the sword name. And okay, so there is only one. Cool. Okay, so it is that line there, 281. So let's shove a breaky on that one as well. Break. Harden sword. Sorry, Menz, I only just saw your question. Why is it 32 minus 1? Let me explain. So you'll see when we do the malloc inside the hardening of the sword, which is just up here, see how it's mallocing length plus 1? Because it's catering for the null byte that it adds here. So, because we know that it's 32 bytes that we want to fill the structure up with, at this point we want to specify 31 so that we actually allocate 32. Yeah? Which should hopefully fit in exactly that spot. That is the plan. Alright, so let's do that again. Yep. Yeah, you're welcome, dude. Skip the things. Continue. Righto, so first malloc brings us to this address. So we go X. Let's go for GW. No, not GW. GX. There you go. So we know that 4 lots. That's the whole structure at this point, right? So we should basically see nothing happen at this point. Let's continue. So then this is the second malloc call. Can continue. And what's going on here? Ah, yes, okay. So we are allocating how much? 32. Okay, so this is doing our next part of the exploit. So we've forged 2. We've hardened the first one, which should have freed it, right? Now we're doing this. So that should mean that when we return from this malloc call, this should be the same as this. Sweet. Okay. So looking at what was there before, it's blank, right? But here we should be able to do... See, it actually starts reading. Please input the name of the sword. So it's just going to keep reading bytes, but that should mean that we're starting to see... Are we starting to see? Aha, there we go. So there are all the bytes that we controlled. Okay, so we have written our name over the top of the very first thing. So does that mean then that... so when we go back to the sword, we go... Rather than equip... Is used. Okay, so anything that's non-zero will work, so that's okay. We know that it's currently in use. So our name length is massive. What I want to do is cause this use sword function. So what happens? Where are we? Equip. Okay, so if we equip the sword at this point, then we should... So equipping the sword is 6. So if we specify 0... Aha! Here we go. Winning. So we overwrote the function pointer with our A's, and as you can see, it's trying to call that, which is awesome. Okay, so we effectively have codexec. Now we just need to figure out where we're going to put things. So what options do we have? We need to... What do we got? We can take a similar approach to what we did last time and maybe play with the GOT. Maybe if there's some way that we can either leak... we could leak a stack pointer and maybe do a ROP chain. Maybe we could overwrite the GOT. I mean, looking at... Yeah. Because the thing is, like, we're constantly calling ASCII to integer and passing in the stuff that we control. One would assume that if we can leak a libc pointer, that we can maybe try and overwrite the GOT. How are we going to overwrite? We don't have a write primitive, do we? That function pointer was overwritten. Yeah, exactly that. So, to be clear, this function pointer here, so remember, we freed this and then reallocated it when we tried to set the sword name on another pre-created sword. So the second sword name points to the same memory space as the first sword, and then we just overwrote everything with for one. So that's how we controlled this pointer. So, okay, so we have the ability to do that, but we need to do something more meaningful with it, really. What can we do? We need to be able to leak something. Like I don't think we have any means to hijack anything useful at this point, given everything that we have the ability to write to is on the heap, and we don't even know where the heap is. Yeah. How do you actually get the flag in this challenge? We just got to shell. I assume we got to shell it. Sword. Can you spawn a shell? There you go. We got to shell it. Yeah. Okay. So we got to shell it. So my vibe, based on what we're seeing, is let's just quit out of this for a second, and I'll go back to my reference material, which I have handy here. View relocation entries. We can go obj dump, which I don't think is sword. Ah, there we go. Righto, so these are the imports. We have 3, alarm, read, signal, mem copy, relay. This one appeals to me because we control what we pass in to this call. So if we were able to modify the content of this, then next time the input is read, it's literally passed straight to this. So we would effectively have the ability to call system with something that we control, assuming that we have the ability to write. So that's what we kind of need to do. Now let's see if we can come up with a means to read stuff first. I mean, the thing that we're using right now, we have the ability to like control the whole structure, including the sword name, right? And that gets outputted. That gets outputted somewhere, doesn't it? So where is it outputted? Apparently there should be system bin sh. Okay, there's clearly a clue. Could be tricky. We need somebody who remembers the difference between PLT and GOT. Yes, please let me know if you find someone who knows. Bastard. Truth hurts, man. Truth hurts. Savage. Cut me deep. Okay, where is this thing? Oh, what's going on here? Oh, look at this. Aha, look at this. You can copy. Right. So we can copy from one sword name to another sword name, and we control both. So there's a write primitive just there. So sword 2, slot 1 and slot 2. Slot 1, slot 2. And that forges the 2. Yep, which is fine. Sword 2. So, okay. Sword 2, combine the 2 together. So we realloc sword 2. Ah, look at this. It bails out if you haven't already given it a name. So sword 2 is where things go to, which contain the stuff that we control. It's interesting that it's reallocated. And probably rather helpful, because we then have the ability to like overwrite quite a bit of stuff straight after Asoy's exit, so yeah, we don't really have that much of a concern anyway. So this looks like we've got a write primitive here. We need to figure out how we can abuse that. But right now we need a read because we don't currently know what it is that we're going to be writing. Oh, meant there's a dig at everyone. It's all good, man. All right, so where are we? There's a printf followed by name. Where is it? Here we go. The name is, the weight is blah, the name is blah. Okay, so when we show the sword. Okay. Continue, continue, continue. Okay, so, whoops. So if we show the sword, which is it slot 3 or 2? I've gobbled up the menu and now I can't remember. Synth is 2, show sword is 3. Okay, so if we show 0, what do we got here? Oof. Ah, okay. Well, we're trying to read from 41414141 for the name, so it's going to fail. So, okay. So at this point, if we just reference one of these functions, like here in the GOT, then we have the ability to read the content of the GOT, right? So if in our exploit we did, sorry, I'm just dancing around with my shenanigans. Okay, so instead of just filling that with A's, we want to have, so the name is going to be, well, I'll call it SN for sword name. Okay, so SN is going to have a bunch of stuff. Let's just quickly pull this out so that we can see it. All right, so we're going to the name length, which I guess at this point isn't really relevant, is it? Is it relevant? No, it's not relevant. So that's going to be the name length, which is just 4. The weight is another 4. The sword name. Now this is going to be, need some more constants here. So address of, what is it? Relocation. So that is this is technically the global offset table, right? So I'm going to use the word got, and I'm not going to address of Attaway. So we'll put got ATOI. Okay, so that's where the got is. Okay, so the sword name is going to be pack64 address of the got. So we want to point our name whatever's currently in the got, which I think is legit. And then we will just go fill this up with whatever characters are left. So that will be length of SN, sword name, max size, no, that's not what I wanted. That's not what I wanted. What do I want? Whatever I'm doing down here is what I want. Sword struct size. Okay. Sword struct size -1 minus whatever it is that we've already done. We're going to fill that up with C. Okay, so then that will overwrite, you know, the hardened bits and the function pointer as well. So that then prepares our sword for getting nailed. So we need to pass in the sword name here. Then we want to show the sword. So we'll have a show 0. And show is going to return the content for us. So let's go with, yeah, we'll call it info for now, and then we'll just print the info to screen and go to interactive. So we want to show 0, and we're going to hope that that's going to spit out something. Hopefully that's going to point to something in the, to this, yeah. Is that what you read already? So does the code push the sword name as a parameter of the used sword? If so, we could overwrite the function pointer to a function-like system and have the name of the command to execute. Yes, that's true. That is a very good point. We could, and then we don't have to overwrite the got at all, do we? We just, yeah, that's a really good idea. We just need to leak. So if we can leak from here, then we can do exactly what you've just described and create a, oh, hang on a second. Yeah, we can overwrite the function pointer. We would need to find bin sh somewhere as well, for example, though, right? Is that right? But you're dead right. We control the name and we control, you know, where it goes. So yeah, we would have the means to effectively do exactly the same thing again, and we would be in a sweet spot. Yeah. Although, hang on. Yes, that's exactly what we would want to do. because inside the source, even though we're printfing with name, we can clearly just backtick escape and we'd be good. Yeah. Oh yes. Sorry, I had actually sorted that out. I don't know why I'm getting beeps again. Hang on. I will solve that problem through other means at this stage. Just bear with me. There you go. You shouldn't be able to hear the beeps anymore. Okay, let me know if you hear something. Sorry about that, John. I know that is a bit annoying, but it's been fading into the background for me, so I apologize for that. Fedora started doing that for me too, and I couldn't figure out how to get rid of it. Yeah, that's so that's in a VM for me, and so I've literally just muted VMware in my Windows sound settings, and now we won't hear anything again. That's the theory anyway, right? All right, we're an hour and 10 in, and I think we're getting somewhere already. I'm feeling quite confident here. So we need to create a def show p index. We're going to go p.sendLine. Show is 3. And we're going to return p.recv until... well, what do we get to? Let me do this manually, because sword, forge a sword, harden 0, weight -1, and then show 0. Okay, so it just says the weight is thing, the name is thing. So what we want to do is we want to read. Basically want to read up to here, don't we? And then we read line. So that's probably what we should consider doing in our exploit. So the name is. So where are we? Show. What we should do is instead of call this show, we should call it get name. We want to get name of whatever it is that we're giving it. So we go send line str of index, because it's going to ask us for that. And then we're going to recv until the name is. Then we're going to go return p dot. No, we're not going to do that. We're going to go data equals, or name equals p.recv line. We're going to read the line, and we're going to chomp off the new line at the end. Then we're going to flush and return the name. Okay, so this will be this should be the address of Atoi. And we're just going to, well, yeah, I'm just going to encode that in hex for now, just to see what that spits out. All right, let's see what it does. Skip over. Come on, I need like a shortcut for this, don't I? Continuing. What happened? What are we waiting for? Reading. What is it stuck on? Might need to output some stuff so that we know where we're at. Let's do this. Print. Overwriting sword structure. Just so that we know that's where we're up to. If I could type, that'd be great. And then we could say getting address of Attoy in libc. Just so that we know where we got to.
Don't pause. Press play. Don't pause. Press play. Don't pause. Press play. Don't pause.
Overwriting sword structure, getting address of Attoy at libc. So clearly I'm not doing something. I love this song. So it's clearly it's waiting for more input from us. So I've failed in something. Let's just quickly do this. So we forge, harden, 0. Oop, can't do that. What's the weight of swords? -1. Okay, so now I should be able to show it. Just give it 0. Yeah, okay, so that's exactly what I would expect, right? Okay, let's do this. Let's print that out. Rec until the name is... Yeah, that should be fine, right? I'm not doing anything... I'm not doing anything stupid. What's up, Eric? Overriding sword structure. Ah! Aha!
Don't pause. Press play.
Okay, so
Press play.
info function toy. Here it is. That's it. That's exactly it. You beauty. That's a win. So we've just leaked Attoy. So if we go info function system, actually we should be able to go, hang on, is system higher? Yeah, it is. P system minus Attoy. So that's the offset between the two. Yeah. Progress. I was waiting for the get system jokes. Alright, so we've got the name. We want to go home.unpack64. So that should give us that. And then we can say Attoy at libc equals, and let's go hex ADR. So then the address of system should be address of Attoy plus that. So what we'll do is go ADR system, we'll go offset system equals that. Nope. That. And let's just write this up. Offset system. And then we can say system at libc equals address of system, and then we can validate that as well, yeah? That makes sense. How was your day at work after the massive stream? I was pretty tired, but thankfully my colleagues all stayed up with me. So we were all absolutely knackered together. Can one get the system address straight without going through ads? Well, we need to leak something, right? But we can't leak. I don't think we still got the relocations here. So system is not in the GOT, and more importantly, even if it was, it hasn't been invoked yet, so we wouldn't know what its address is. So we need to leak something that we know has been resolved. and then get an offset from that. Yeah, cool. No worries. Worst that here ever. Sure is purely voluntary. Yes. Yes, let's go with that. Thank you for the follow, mate J or Matage 88285. Thank you for the follow. ASLR will affect those addresses, absolutely, which is why we have to leak them, but it won't affect the offset between them because they're always going to be the same distance in memory, which is why once we've leaked Attoy, we should be able to do all the things. Continue. Why is that hanging? Yeah, I was using the hard-coded offset, but I wasn't using a hard-coded address. I don't know why that's not working. What have I done? Yeah, does that make sense? Yeah, because the whole library is moved to a different location in memory. But once you've found out where Attoy is, the offset to system is going to be the same because they don't have like function level rewriting of ASLR. Second recv until after you... that's a good question. I'm doing something dumb, clearly, and it's just hanging. Okay, so we send... I wonder if it's got something to do, like the first thing that we print out is the weight. Let's quickly check the code and see what show sword does. Okay. Okay, so it's definitely used. We then... If that's 0, then... That's bizarre. The weight is unsigned in... Yeah, okay. So the weight should just be in any old value. And then the name is obviously the value, the pointer that we've pointed at the got. So that should be okay. Maybe I need to... Hey, Binchuk! Address got Attoy. No, the address got Attoy is a hard-coded BSS address that is where the PL... Is it the PLT or the GOT? One of those two. Actually stores the pointer to Attoy in system. And because the binary itself that we're hacking doesn't have ASLR, so check sec. So there's no PIE for this binary, so that we know the address for where the table index that points to Attoy is. We know that we can hard code that address, read that value, add the offset to that value, which will take us to system, and then we have our pointer ready to go. Yeah, oh, okay, cool. Okay, there we go. Then that makes sense. All good? Awesome. Apologies not required, mens. Okay, so what I'm going to do here is I'm going to break this up into... So after this, I'm going to go print p.recvline, and then I'm going to go print p.recvline again. And then here, I'm going to go name equals recvline. Actually, I can get rid of that. Print name. Maybe it's this flush that's killing me or something. But anyway, let's just see what those steps give us. Continue. Oof. Okay, so... there's like an extra... Oh no, there isn't an extra new line. The name is whatever that happens to be. Unpack requires a string argument of length 8. Well, that makes perfect sense, doesn't it? Okay, so what we need to do is so we know that the name is right now, but we need to basically remove the front bit. So let's just comment these out for a minute. And so once we've got the name, we're going to return name, and we're going to only return a slice afterwards. Polyhistor, thank you for the follow. Welcome to the stream. Let me just grab a copy and paste of this. So we're going to grab that and take off the new line at the end. And that's what the name is going to be. And then once we've received the name down here, we've got the name. We want to pad that with bytes. So we want to go, is it L just? Oh, hang on, which way? This is going to do my head in. Left justify, L just, 8 null bytes. And that should sort it out for us. Okay, continue. No. Something is very strange. Let's do our skipping over. Overriding sort. Ooh. Something worked a little bit better that time. Unpack requires a string argument of length 8. Yeah, so that's what I would have thought that we got. Name equals. I'm going to encode that as hex so that we can see it all, and then no. I'm not going to do that. I'm going to print name, and then we'll go name.encode hex. Okay, let's try that just to see what we get. I'm so confused. Oh, yeah. I still need to do the recti lines. I'm so dumb. I'm so dumb. That makes way more sense. This should work now. My problem was that I commented out the recti lines and I actually needed them. I thought I was just commenting out the prints. Oh, hey, okay. That makes a little bit more sense. Info func system. 7EFF8A FFA390. Boom! Would you look at that? Okay, so we have the address of system. So now we can literally do the same thing again by forging. We can even forge 4 up front. In fact, let's do that. Let's just create a few more. So at this point, we should be able to forge we want to do the same thing. And when we do, we want to free up the second or third. Let's go with the third one. And then overwrite that like we did before. And all we need to do is specify a pointer to the name. Oh, see, we don't know what the name is going to be. We're going to have to find a reference to binsh. Search mem bin. There's going to be one in systems in libc anyway. So libc.so.6. There you go. There's one. So if we go p that minus whatever attway is, then that's the offset to binsh. Okay, so address offset binsh equals. Okay, so then let's do the same thing here. Address binsh equals that plus address offset binsh. Let's rerun. Get rid of the alarms for now. Continue. Alright, so if we look at this and we go XS that, binsh. Okay, so we have an address now for binsh. So we can overwrite the name pointer to point to binsh, and we can change the function to point to system. Ah, okay, so here's where we've got a problem though. It's never going to be that easy, was it? So I was hoping that we could point... Hang on. Yeah, so... Sword name. This gets passed to Bree. The problem that we've got here... Oh, hang on, here we go. This thing here. Where's that really small one? When we equip the sword... Yeah, okay, so it is. Yep. So we just need to equip the sword once we've constructed one that fits. Okay, alright, sorry, my bad. So... all we need to do now is... We'll do the same as what we did before. We're going to construct one of these after we've hardened another sword. So we're going to harden the 0, 1, 2. We'll harden number 2. Do what we did there. This time we will... Now the name that we wanted to pass in is the address of binsh. Right? And then immediately after that, is it immediately after? Yep, the name, we have a pointer. Okay, so we want to do the address of system. And then we can pad it out with just nonsense. Okay? So at that point, all we need to do is equip, can't type, P, and the sword that we want to equip is number 2. Oh, we need to harden that other sword, don't we? So we need to harden number 3. Sword struct size -1 SN. Okay, and then we equip the second sword and magic should happen, yeah? See what happens. Equip is not defined. Ah, I'm such a numpty. Let's define it then. Def equip. key index. Now it's number 6. So we need to, what do we need to do? We need to send line 6. Then we need to send line of str index. And that's it. Yeah? Does that work? What's the index of the sword? What happened there? Zigzag V. Ah, something went wrong. We're off by... Oh, I got my structure thing wrong. I've missed something in my structure. Name. Oh, it's because okay. It's because these, I'm assuming, are aligned. Oh, no, they wouldn't be aligned, would they? We know that this structure's 32 bytes, right? What have I done wrong? JDs and Lentilman? Rax points to the C's. And the string that we were passing to it points there. So it's like we're off by... That doesn't make sense. What have I done wrong? Missing the Rex? Rex? What do you mean Rex? Has it got something to do with the fact that maybe the address has spaces or something in it? That shouldn't matter. Clearly the pointer is pointing to where I want it to be. Hang on a minute. Am I equipping the wrong sword? Yeah, I'm equipping the wrong sword. Okay, hang on a minute. How about we do this? Let's take these. And put this stuff down here. I think I've just got my indexes wrong. I bet, yeah, that's what my problem is. Yeah. Done something wrong here. So that's still doing the same. And it's still pointing to... So see there, we've got this, what's the index of the sword? I would have expected that to be elsewhere. Okay, let's just quickly regroup. If we run it, and we forge one, and then we harden it, we harden the first one, -1, and then we equip 0. Yeah, okay. What's the index of the sword? Okay, so that's okay. That's doing exactly what I would expect it to do. So once we have this stuff, I'm going to move these forges back up here. 1, 2, 3, 4. So we just have 4, because I'm going to use the second and third after the fact, right? So when we harden, we've got 0 and 1, we're going to harden number 2. And then we're going to harden number 3 and equip number 2. That to me doesn't seem wrong, yeah? Hello, Genrise, how's it going? It is indeed Python. It's rather nasty bastardized Python, I will wholeheartedly admit. So yeah, something is going on. Oh, hang on a minute. When you equip a sword, yeah, that should just work fine. We're just finishing off a binary exploitation challenge from PicoCTF 2018 called Sword, and we're very close to shelling it from what I can tell. You just need to figure out why it's not kind of doing what I was expecting it to do. So maybe what I should do instead, if instead of hardening 0, if we harden 2 and we harden 3, and then here we harden 0, harden 1 and harden 0. Let's see if this makes a difference, and then I'll give you my rationale. So we're still able to leak stuff. And it's going to bail on us. This is interesting. It's like we're stuck. Okay, let's just go print hardening 0, just so that we are aware of where we're up to. Hardening 1, equipping 0. It's definitely different behavior though, right? Let's just check our pointers again. Info F Atoy. Ooh. Oh, I know what that was. Okay, so we get to hardening 1. Why is that failing? Why is that failing when we get to hardening? Thanks for the follow, Nocturnal. 15 minutes. Is this going to be that little thing right at the end that prevents us from shelling that's going to cost me the rest of the night? I hope not. Let's put some debug prints in. Maybe, yeah, deja vu. Okay, maybe. Let me just put some print in here. Harden. I'm just gonna go step 1. Dot format. Index. Like so. And I'm just gonna do this because I like to know what's going on. And then that should at least give us an idea of which stage we're at. It's always the 10%, that's right. That's so true. T-minus 5 hours. God, you guys, you have no faith in me, huh? No faith. Based on the last stream, I can't really blame you guys for having that stance, I'm not gonna lie. Okay, so hardening 1. Maybe it's the flush. Maybe it's the flush afterwards. Let's see what this does. And then for our very last one where we're hardening this, we would say don't flush at the end. And then before we quit, let's just do interactivity and see what gets coughed up. Okay, please wait for forging the sword. Please wait for forging the sword. Ah, okay. We've got to wait for the sword to be forged, which is... Hang on a second. Wait for forging the sword. I didn't ask for it. Hang on. Wait for... What is this doing? Aha. Okay, so we harden. Oh, there you go. We need to make sure the weight. Yeah. Whoops. Okay, so that means... Hang on, so that's done in... when we're hardening. What's the weight of the sword? Why are we not giving it -1? That's interesting. So something's up. I'm gonna sneeze. Excuse me. It's not COVID, I assure you. It is not coronavirus. Okay, so that's definitely freed up the first. Oh, hang on. Wait up a minute. Something is not right. I'm going to put this back to harden 0 and then harden 1, and then we get the name of 0, and then down here we're going to harden 2, three, Yeah, I'm a little bit confused by what I'm seeing here, because I would expect that hardening would have set minus 1, right? Yeah, but this is the thing I don't understand. So we're overwriting, we harden this one, which hasn't been overwritten yet. So it's legitimately -1. And it works fine because you can see it here. Okay, so we've hardened 0 and 1, 2 and 3. Please wait for forging the sword. Okay. So, hang on. If we now equip a sword, and the one that we equip is 2, there you go. So that worked, right? Yeah? So we can actually put our put that back in. We want to equip 2, run interactive. And the thing is, we're actually going to time out. So we're probably going to need to go and automate the process. So if we can go something like p.sendLine cat flag, then because the timeout thing is gonna kill us, right? So if we go cat into flag, just to make this is the flag. Woo. Okay, so now we've actually got a flagged cat. If we exploit and just run, there's the flag. Okay, so then that means if we just do this remotely, come on, come on, come on. Ah. Ah, really? This is concerning, isn't it? Why is it saying what's the index of the sword? Have I? Oh, it's, yeah, okay. It clearly didn't work, did it, hey? Friggin' hate these Christmas tunes, man. Why do they appear? Let's change the tunes over. I don't know why that keeps appearing. I don't remember adding that to any of my playlists. Okay, so why is that failing is the real question. So let's get rid of some of that debug output. Where am I looking? Here we go. I'm going to just close some of these down for a sec. I'm going to do the... I'm actually not going to attach it for now. I'm just going to run the process by itself and see... Ooh! What was it called? Sword. Leaving exploit. Sorry about that. Certainly inconsistent, isn't it? Jesus, that was quick. It's slow. That looks better. Ah, no such file or directory. Hey, there we go. There we go. And it's almost bang on 2 hours. Yes! You. Okay. I'm so glad that that didn't end up going for that long. Yay! Second challenge. Don't even tempt me, Wilbur. No. We have pretty much hit the 2 hour mark, and that is it. So we're going to punch our flag into sword and just enjoy seeing the little... Yay, that is correct. Yes. No. Second one. Oh, yeah. RFC hacks. Dude, seriously, you just want me to be awake when you finish work, and that's not going to happen. Okay, so did everyone fully understand what we did there and how we got there? I am not doing 10 hours. We're certainly not kicking off at 8 o'clock at night. Are there any questions around what it is? You see this? I forgot that we actually had the local thing. I could have just used the symbol table in here and said, okay, well, you know, give me the base address and blah, 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 and get it to figure it out for me. So I wouldn't even have to have these hard-coded offsets. The TLDR. Okay, let's do a TLDR. That's a very, very good call. Okay, so here is the problem. You can go through and you can create swords, okay? When you create a sword, there is an array of swords stored in memory, right? This sword list. Okay, and there is a fixed number of swords. Okay, and every entry in this list of swords has this sword list structure. It has a flag that indicates whether the sword structure entry in the array is currently in use, and then it has a pointer to the sword entry. Okay, so when we create a sword, what it does is it looks for the next free slot in order to figure out where to put the sword, and the free slot check is literally just has this slot been marked as in use, yes or no, and it's not using the pointer as a means to determine that. So once it's determined the slot to use, it just allocates enough space for a sword structure, indicates that that slot is in use, and indicates that the sword has not been hardened. Okay, now when you harden a sword, when you harden a sword, so what happens here is it basically says, if you're not hardened already, if you are hardened already, obviously we're not going to do it again. And it says to you, what name do you want to give it? And the first thing that you need to tell it is how long that name is going to be. So you can say, I want to give the sword a name of 10 characters, and it will allocate enough memory for that many characters, store the name, and off you go. However, if you give it too many characters, so if you say to it, oh, I want to give it a sword name that is more than 256 characters, this is where we hit the issue. So straight away it frees the sword, and that's it. So it doesn't mark the sword slot as ready to be reused, which basically means that according to the rest of the code, that sword still exists and points to an area of memory that has now been freed. Okay, so that's really important. If you don't do that, then and you give it a value that's less than this max sword length, then it will allocate memory for you, etc. Now this is important because this is the thing that you use to write to existing areas of memory. So if you can imagine, we have two swords Okay? Neither of them have been hardened. Okay? So with these two swords, we free the first one. So that would be your left. Looking at the camera, hang on, I should see myself. Because maybe this will be helpful. Okay, so this side, this is the first one, this is the second one. So this gets hardened, and we say, we want to harden this with a name that's way too big. At which point, this sword entity gets freed, but it's still in use as far as the global array is concerned. Then what we say is we want to harden this one. But with this one, we give it a name length that is exactly the same size as a sword structure, which means when the memory allocation kicks off, it will allocate the memory for this spot here that's been freed. So the name associated with this sword points over here to the memory that's associated with this sword. Okay, so then we can overwrite this whole sword structure with the name over here, which means, looking back at our code over here, we have the ability to control all of this information in the very first structure. Sorry, this side, the first structure. Okay, so we can control the name length, we control the weight, we can control where the name points to, and we can control the function pointer that's associated with it. Okay? Now, so what we do is we point the sword name at an area inside the GOT which contains the address of the Attoy function, right? And so then later on we can say, show us the current, show us the sword, and point it at the sword that's actually been freed, which is now pointed to by the name of the second one. And at that point, it will spit out whatever that thing happens to point to, which we have pointed at the GOT, right? So the entry inside the global offset table points to the address of Attoy inside libc. So that leaks the libc address, because here you see the name is this sword name. Well, we've controlled sword name at this point to point over to libc. Okay, so that spits out the address of Attoy, which is this. Okay, so we can spit that out. So from there, we know where libc is in memory. We can figure out where system is, and we can figure out where binsh is, which is classic offset calculations. Okay, so going back to the code, you'll see that we can also equip a sword. And when we equip a sword, hang on, if I can find the function. When we equip a sword, all it does is it checks to make sure that it's actually still in use. And then it uses the function pointer that's associated with that sword. And it calls that function and passes in the name of the sword. Now, by default, this points to that function called who. And all it does is printf. Easy peasy. So what we want to do is overwrite that use sword function pointer to point to system, because we now know where that is, right? And we want to set the name to binsh, because that would then have the effect of replacing this with system, replacing this with binsh, so we end up calling system binsh, just like this helper comment has implied. So in order to do that, we follow exactly the same process that we did before, where we have two other swords in the same scenario. We harden the first one with an invalid name length, which causes it to be freed. We harden a second one to point to the first one again. This time, we just overwrite that structure so that as we're writing, we don't care about this, we don't care about this. We point sword name at binsh, which is in libc, and we point use sword at system, and then we call the equip function on that freed sword, and we end up with system binsh being invoked. And that's it. Live step. Thank you for the follow. Does that make sense? A little bit of a roundabout kind of way, and certainly a significantly easier challenge than the one that we did last week. Hey? Whew, man, that was a mind job. I'm going to do a 30-minute condensed summary of that video for the Patreons, because I think that would be really useful. Is there a name for this kind of vulnerability? Yes, this is a use after free. Without a doubt, this is a use after free. So we have one area of code freeing the memory we then can reallocate it and control it for our own means, and then we invoke other areas of code that assume that that first freed area of memory that was now used for other stuff is still in the structure that it was intended to be in. So we've got two things pointing to the same area of memory for two different purposes. So it's definitely a use after tree. Pleasure. I do need. I'd happily do a charity stream, but you know, what would that look like? What does a charity stream look like? How long does it go for? Which charity do we raise money for? What would the goal be? How do we get more people to come in and pitch in? You know, what sort of thing could we do? I'm certainly open to ideas. But on this note, it is 10:05, which means I'm 2 hours and 5 minutes in. Basically, bang on 2 hours if we exclude the nonsense of mucking around with sound at the start of the stream. So, yeah, well, if there are no more questions, then I will sign off for the evening and just be stoked that we actually got a shell well and truly within our time limits. Tom K. Would this work equivalently with a fully hardened modern binary with PIE? I would say you would need to find... I don't know. It could be a fun little thought experiment to go and do that. But we need to be able to leak addresses. We need to be able to leak addresses inside the binary. So if we could leak addresses, we just need one address. We need to be able to leak one address that points inside the binary, and then everything else would come unstuck. So you know, we could have a play with it. You never know. So yeah, I would say that it's possible, but I would have to investigate that a little bit more. Fully hardened binary, I mean, we're not overwriting the GOT and we're mucking with function pointers, so I would say there's a pretty good chance that this would fall with a bit of persistence. Yeah. RFC Hacks, thanks again. Yeah, pleasure. Thanks for joining the stream. Always good to have you on. Thanks, Serializing. Do your VODs post after stream. I got here late and would like to be able to watch the full stream. Yes, Chill Guy 269. I post them on both YouTube and on Vimeo. So if you go bang YouTube and bang Vimeo in the chats, they're the chat. I post them on both. I tend to recommend people go and use the Vimeo link because Vimeo does a better job of uploading the higher fidelity prior to YouTube. So I'll be doing that as soon as we're done. I'll be uploading those videos and they will become available to the unwashed masses. But yeah, give it a little bit of time because they usually upload them at 360p or whatever it is to begin with, and then behind the scenes they process them at higher qualities. So yeah, that's where you can dig them up. Thanks, Siv. I appreciate you all very much for being part of the show as always. Chill Guy, you are most welcome. If you have any issues accessing it, then please hit us up on the Discords, which you can jump into there if you're not already. And yeah, pleasure having you all as always. Thanks for your support. Yeah, until next time, be good to each other.
Tried a little more just to act like them. Play my video.